Hello, my name's Adam John Richardson. Let's talk about hypothesis testing, specifically type 1 versus type 2 errors. First, a quick review. We typically set up a null hypothesis when carrying out research. Our null hypothesis, we can state it formally here, the null hypothesis for these populations is that mu1 minus mu2 equals 0. Essentially, these means, statistically speaking, for the two populations are the same. Or we can write it in terms of samples. The mean for sample 1 essentially equals the mean for sample 2. If we subtract them, it should be 0. Sure, we understand it's unlikely to see the exact same value. It'll rarely be 0. However, we are saying, in terms of our theory, that we're going to need to see something extraordinary to say that these two values are not equal. We can actually associate probabilities with seeing the difference between the means in two samples. And we use this to say, all right, let's set a value that if we see this, it's so crazy to see this, randomly speaking, that we're going to attribute this to some type of treatment effect within our experiment. Now, what can we do to describe this? Well, this is what we refer to as a priori. Wow, these look like song lyrics. Let's try something. Hey, this is better. I think I hear a tune in this. A priori, you have to select the testing criteria before a priori. Don't change them later or the scientific community will be sorry. Wow, it rolls right off your tongue. You'll be singing this for days. All right, let's go back. Wow. I mean, come on. The lyrics, the melody, the guitar playing, it was the complete package. So let's move forward. Now that we know a priori, the idea that we have to set things ahead of time. We can't change them after the fact and say, oh, this would have made it look like I found something. I'm going to change my p-value or change whether it's a one or two tailed test. We'll talk about this now. So p-value is something we set a priori. It's that probability of seeing this type of effect size. And so we typically would set this to 0.05, which means if you run this experiment 1 out of 20 times, you would get this type of sample difference in terms of means by chance. 1 out of 20. That gives you pretty good confidence that if you see this type of difference between the means here, then we can say, you know what, let's reject the null hypothesis. What we're seeing is related to some type of treatment effect due to our experimental design. Now, this represents a two-tailed test. We can take that probability, the 0.5, and we can put it at both ends, which means the means could differ in such a way where one is higher than the other or one is lower than the other. And we'd catch either. And we put part of this probability at one end and part at the other. But we can also set this up in a one-tail test. Again, a priori. If you have a reason to believe that you'll see that there's a treatment effect that leads to improved scores, you could just go looking for improved scores, and then if scores drop, you're not looking for that. Even if it would have been in a normal two-tail test, you can't change later. You have to choose ahead of time and stick with it. Now, once we have this set and we've chosen whether it's a one or two-tail test, then we look at our null hypothesis. And there are a few ways that this can go. This gets to the point of type 1 and type 2 errors. Our null hypothesis could be true, which just means there really isn't a difference between these two populations or these two samples. It just happened randomly, the 1 out of 20 that we talked about before. Or it could be that the null hypothesis is really false and there really was a difference here. There was some type of treatment effect. Well, what we do with this, whether we reject the null hypothesis or accept it, herein comes the potential errors. As you see, a type 1 error here would be if the null hypothesis is true, which means they're both the same, essentially, but I still reject it. I actually ran the experiment, and it was one of those random times where I just happened to see this type of difference, but it was due to random chance, to error variance. That's a type 1 error. The way you can remember this is the, oh, I found one error, hence type 1. You found something, you think you found something, oh, I found one, but actually you were in error. And then the other type 2, is just the opposite. I could, the null hypothesis could be false. We really could have a treatment effect here. But I might run my experiment and just randomly, because of the other error variance that's involved, I might miss it. And I might decide to accept the null hypothesis. Hopefully this helps understanding type 1 and type 2 errors, and I will see you later. Bye.